right here? So how would you do that? Oh, you actually do the drawing itself.
There's a pen, yeah, right, so you just feed it a two-dimensional file as opposed to a three-dimensional file.
Oh, and it would draw the image. Oh,
right, so we have there's a little ballpoint pen right here.
There's the pen, so you can actually draw on the
It's
item.
a little like spring-loaded ballpoint pen.
But what would be the point of drawing on the object when in fact you could just take out a pen and draw on the object?
Oh, but look at this. I mean, have you ever drawn something like this?
Have I drawn something quite like that? Not exactly like that, no.
You're a better draftsman than
so
I am.
this was actually drawn by that?
Yes.
Okay,
yeah.
I got it.
Yes, and it's more like, you know, in this case it's more just a proof of concept, because we don't always want to be running it. It's kind of loud and dirty.
Right.
So we like to use the pen for demos.
Oh, okay, I see. But it's essentially a do-it-yourself milling machine.
Yeah, absolutely.
Here's the info. This year at SIGGraph, things are being run a bit differently. So out here is the different kind of milling machines. They use the rapid prototyping. This one is the MakerBot over here. And this we saw yesterday. And just now there's a milling machine, CNC milling machine, kind of a do-it-yourself device. And I'm going to be coming back later to do a company logo, and it'll be cut into wood. There's workstations to do it. So this year they're putting some of the studio out here in the hall area, and then more of the studio is going to be inside. So if we look over here, here's more of the rapid prototyping machines, and in this case, again, something that was done with a CNC milling, it looks like, that has been cutting the device, cutting certain material, but it's been thousands of pieces of this material, then it gets glued back together. It's a pretty amazing piece. Here's another part of the studio, and in this part, they're making inflatables. You can actually produce these patterns in plastic, then you're going to be gluing it together, not gluing, it's heating, ironing together. And this is the young lady I've known for years here at SIGGraph, and she's running this part of the show.
I've got my patterns here, right? I need two of this one.
She's showing the different patterns that gets created.
Print screen. I'm going to open Photoshop and generate a JPEG, so it's just a picture. And then I'm going to bring it over here to this computer and project it up. So if you guys
and then the computer then projects the images up on the screen. And once they're projected up on the screen, you put a piece of plastic on the screen, you trace your picture, you're tracing it. And once you trace it, then you're going to cut it out. And once you cut it out, you're going to be using these different devices to iron it and glue it together, basically iron and heating it together. Now over in this area is a whole another new section. This is both of these items, the plastic pieces. And this section here is actually putting some sort of electronics in the clothing, which I'm going to be doing also. That you're talking about here that's going to be generating these patterns, you're drawing in it, or what are you doing?
Yeah, so what you do is you draw the 2D outline, I guess, the
shape,
and then what you do is you specify that some areas need to be doubled. So for example, legs or ears, you want a stereo version of them effectively.
Oh, okay.
And what it does is it generates the inseam that you need to cut and, I guess in this case, fuse to generate the full 3D form.
I got
But you can also specify what's called, I guess, a gutter for 2 layers, so you can give things width and depth as well.
Okay, so that's kind of the thing to give it a little bit like more bulge, to give it that more of a 3D depth. Otherwise, you're making something that's flat, and if you blow it up, you're not going to get enough 3D depth kind of thing to it.
But it's not taking it to the full extent of designing a full 3D model,
right? Because
that tends to introduce, I guess, too many seams. It makes it quite complicated to construct. Right.
Okay, sounds good, and I'm definitely going to be trying it out later today. Thanks. And your name is?
David Ribley.
David Ribley?
Brimley.
David Brimley. And where are you from? Unlimited Realities. Okay, thanks.